I am sure you are wondering if 16 gigabyte of RAM is enough when you are using the Apple M5 chip for the MacBook Pro, whether you are using the 14-inch or the 16-inch. So we're gonna test that today. Here we have a few projects, and the project that we will be working with called a Blender Party Tug. So we are opening the project right now, and we are using Eevee, and then the samples are 16, and this is the project right here. In terms of a Blender, we are using a Blender 5.0.0, and then in terms of the Mac, we are using MacBook Pro 14-inch 16 gigabyte of RAM with the Apple M chip. We are going to preferences, and we are actually using the Apple M5 GPU, and we are not going to use the CPU or the CPU and the GPU together. If you are wondering about that, check Blender breakdown on the Apple M5 chip as to why you should not be using the CPU and then the GPU together, or the CPU only. But the long story short, they are slower than the GPU. The GPU is the one with the better performance. With that being said, this is actually the monitor, a Blender right here, and as you can see, when we go to the kind is actually Apple. That means that Blender is natively supported to Apple, but that's not what we care about in terms of the CPU or in terms of what the architecture or the SoC is running. We care about memory. So with memory right now, we're looking at memory used of 9 gigabytes. We have cached files of about 3 gigabytes, so 2.9. And then we have a swap memory that we actually gotten into, and it's 1.11. And then the total physical memory is about 16. And here we had a spike, and probably that spike was due to me opening this project right here. Now, in terms of the cached files, when you are opening your Mac, it will actually cache some software in, and it would say, oh, this software that is being cached, probably the user or the Mac user is gonna open that software. Let's say it's Maya or Blender or whatever. So we're just gonna save it because we know that they are gonna use it. Now, if we end up not using it, this memory, we would have access to it. Otherwise, the last, let's say, resource it will jump to is the swap memory when it needs. The swap memory is actually using your physical hard drive that is on the device, which is fast, so you don't need to worry about that. In terms of a Blender is using about 3 gigabytes. I have a feeling this is not the correct number, and again, there's a lot of processes that are working in the background. So for example, this compiler service is taking about 441 megabytes. So for the total memory used, we are looking at 9 gigabyte from a total of 16, and we are in the green. First things first, I'm gonna go ahead and change to cycles, and when I'm gonna change to cycles, this is GPU compute, and with the GPU compute, what I'm gonna do is I'm simply gonna go and render an image. And while the image is rendering, we do not care about the numbers. If you care about the performance, watch my previous videos where I did a full breakdown of the performance, and then you can get a better representation of what the performance would look like. What we are worried about is how much a Blender is using when you are rendering something such as the project that we are working in right now. And basically, it's taking 5 gigabytes. Now here the compiler service did jump in. The first one is taking about 2 gigabytes, and the second one is about 2 gigabytes as well. So that's for a total of 4 gigabytes. In terms of the swap memory, we are using only 1 gigabyte. In terms of the total memory used, we are using 14 gigabytes. So basically there is free 2 gigabytes ish for the system. But as you can see, it's actually going up, but we are still in the green, and this project is rendering. And as you can see, the compiler service, it did even jump, and we are at 2.3. So basically this by itself is about 5 gigabytes. So 5 plus 5, that is already 10, and you are at 16 total. So here you have 10 gigabytes just being used by the compiler and then by a Blender as well. So Blender does take about 16 gigabytes if you are working with projects such as the Party Tug. Now I want to explain something. This is an SoC. That means your CPU and GPU, they are combined into one chip. The RAM that you have, or the memory that you have, is being used by the GPU, and it's being used by the device itself. So you have only 16 gigabyte of RAM. So think of it as the compiler service is basically your GPU at work, and then here your Blender is basically using a typical RAM. And actually, we can see that live. So here what we have is the GPU history, which as you can see right here, we do have the CPU history. Now the CPU, we have the efficiency cores right here, and then you have the performance cores as well. So basically everything is divided in a really nice graph. So we're gonna put that in here. Right now we do not have a lot of data to look at or to work with, but when we are going to run it again, I'm gonna go ahead and render. Now this is rendering. In terms of the activity monitor, right now Blender is taking about 10 gigabytes, so it's taking way more. And then in terms of the compiler service, we're looking at the 3 and we're looking at 2. And as you can see, when the render was done, we slowed down a lot, and now that we are rendering again, it's jumping to the top. But the CPU is not working at all. As you can see, the CPU cores, they are sleeping. We're only using the efficiency cores for the GPU, and that is about it. Otherwise, everything else is sleeping, and the CPU does not have any pressure. But that makes sense because in Blender itself, we are here using the GPU compute. Because of that, it's actually doing what it's supposed to, which is using the GPU and giving us the performance that we want from the GPU. One thing I want to highlight here, we were in the red when it was rendering very heavily. Not necessarily red, the yellow, that means we are getting really close to like the bottleneck of the RAM. So this only took 1 minute to render the scene. And while this was rendering, the GPU was at the peak, and then the RAM was struggling as well, as you can see here at the bottom, which is understandable as to why that might be the case. Preferences, and I'm gonna open the CPU only. Now, I do not recommend that you use the CPU only to render, but what I am trying to showcase is the difference between the GPU history and then the CPU when we are using the CPU only. So let's go ahead and render. We do not care how long this would take. I will share the numbers with you, but that's not our main concern per se. Our main concern is CPU is like vroom. All of the cores went full bazingas. They are working like there is no tomorrow. Like everything jumped right away. As you can see, the GPU is chilling. The CPUs, all of them, the pressure is way less because right now we are still in the green, and the swap memory, we are using only about 12 gigabytes in total, and then 1 gigabyte of a swap is still there. I think the 1 gigabyte for a swap is basically for something that the machine is doing itself. It's really interesting to see how the GPU and the CPU are different. So when we open a Blender to see how much time we have left, we have 1 minute and 30 seconds, which I believe is enough data for us to see how all of these perform. But as you can see, the GPU is barely being used in comparison to when we used it the first time. So everything is slowing down right now, and as you can see, there is no more pressure in terms of the performance. Now we're gonna go ahead and go to preferences, and we're gonna use both, even though I do not recommend. And we will see what would happen. My prediction would be we would get to a bottleneck when that is the case. And we're gonna go ahead and render again. So right now the CPU is going full blast, and you can see that here, and the GPU is going full blast. Let's see the RAM and what it does. You see, we got in a bottleneck because before it was only the CPU. Now, because we are using the GPU and the CPU, we are getting a bottleneck, and the memory is getting into this yellow area. That means it's just under a lot of pressure, and it needs way more than 16. Even if actually you have 64 gigabyte of RAM, which is that's what I have with my M1 Max MacBook Pro, it will still do that because usually you are having two components, and those two components are clashing, fighting for resources. So that's what ended up happening, and I think Apple have yet to, let's say, find a solution for this, or even a Blender. But as you can see, it's really bad. Back into the green because our render here is over since it took 1 minute and 21 seconds. In a general sense, you should not be using both of them because you will have your resources clash. I'm gonna go to edit and then preferences, and then with the preferences we will only have the GPU, and then we're gonna go ahead and render. With this, we should not be seeing the CPU spike at all. The CPU is gonna be chill, but we will see the GPU being a spike and going up high. We should not see our resources in terms of the RAM going into this yellow dangerous area as well, should be staying in the green, because we are not having our resources for our Mac clashed. Setting up your render in a general sense would play a big role in terms of how your Mac would perform overall. Now, we are using a lot of RAM, yes, up to 15 gigabyte almost, but in a general sense, we do not have resources to clash because our CPU here, as you can see, is sleeping, and the efficiency cores and the performance cores can show you that right here, but the GPU is being used like there is no tomorrow. And because of that, it actually only took 1 minute in comparison to the previous number that we had, which I believe it was like 1 minute and 21 seconds. That's what you get when you are working with a Blender, and how much RAM it's using, and how the GPU is working, and what your activity monitor looks like. And I hope that gives you an idea of what to expect. And if you want to see more of that, you know what to do. Basically subscribe and like and that fun stuff.